Hey, hello. So, seems like there's nobody here yet. I will just wait for a little bit. Um, yeah, it's 4 p.m. now in London. So it's Friday afternoon. So I decided that maybe Friday afternoon, people will be, more relaxed. It's at the end of the week. I've been working very hard. Yeah, so maybe I should regularly do it every Friday, just to talk about a little bit about like things, maybe things I learned this week, um, just as a recap, or just like push myself that I could learn something new every week, so I would have something to show you, the viewers, that you may learn something as well. So today I won't be talking about something new. This is actually my talk that I did in Open Belgium. I was kind of the last conference before everything got cancelled. Yeah, so it wasn't recorded. I was planned to give it at another meetup or conference that hopefully this will be recorded, but it seems like it's not happening at the moment. So I decided to record it myself. And also, if you join me now, then you would help me to see if the quality of the video is fine, see if my presentation is good. Hello? Yeah, I don't know why my headset likes to switch off when I'm streaming. It doesn't happen when I use on Discord. It's just like it just go dead sometimes. I still don't know why. Um, but yeah, I would have to figure it out. And but now I'm just like paying attention. If my microphone die, I'll just like go back and switch it on. Maybe I get another microphone like those that people do in the podcast. Those like more professional mics. But anyway, I yeah, there's one person coming in. I can see in the chat. So if you can say hi, that would be great. That would be helpful for me. So yeah, I think I won't just chit chat too much. I'll just go to start. So, I'm Chuck. I'm currently working as a developer advocate for TerminusDB. We are a super cool database. You will know why later. But yeah, like at a time like this, everything needs to be done remotely. Will be a great help for people who need to handle a lot of data. Yeah. So this is about the knowledge graph of the whole human history. So wow, it sounds amazing. Like whole human history, how big is it? Like we know that history helps us a lot. For example, in this pandemic happening right now, we can see what happened 100 years ago. The Spanish flu. Then we kind of know that we have to be careful and how we gotta tackle this problem. So history is very important to us. Um, but how much do we know? We must know a lot of things, right? Because since we have writings, people invented writings. We have documented things. Maybe start from carving things on the cave, or even later in some metals. Then actually we are documenting a lot of things. There's a lot about history that we know. Um, so let me introduce you this. This is the Shasha Global History Data. It's amazing open source data. There are lots of information in it. It composed of a lot of um, research by the historians. So they are all like gathering information about the humanities around the globe. So we have lots of data. There, like most of them, is in RDF format, which is a format that is described by W3C. If you're interested, you can have a look, or if I can find a link, I can post it in the description when I upload this video. But it's a format that is standardized, but everybody have their own standard. So when you use the data, you have to know how they structure the things. So we have a lot of RDF data. they may or may not have the same format. We also have lots of variables because history is very complex things. So we have a lot of different things that they are all, relate to each other in different ways. There are also, time structures as well, because for example, some society, some let's say dynasty, they evolve one after another. We call them polities actually. So polities will evolve, and a lot of them would divide or combine, and it's a complex thing. Um, Also, some of them would be, like human entered data. So there may be errors. So if people who work with database, they know that like this is horrible thing, right? Like you have to parse the data, double check if the format is correct. It could end up in a disaster if you don't take care of it. Actually, I'm hiding the words here. I'm gonna dodge and let you see. Yeah, it's not that important. My talking is more important. Okay, so we have a large amount of data. They're mainly in this like kind of structured RDF format, semi-structured. I would say it's not like a table, but it's things related to each other. It's very complex, um, and some of them may not be clean. So if you can imagine, if you store it in a tabular format in CSVs and then upload it to a SQL database, it's a disaster. How are you going to link up all these things? Million joins, a lot of keys. Um, you may make mistake doing that. And when you retrieve the data, you have to write thousands lines of SQL code. It's not fun. I have done it before. I was a data scientist. I know. You can spend your whole day just writing SQL joins and just want to get that simple aggregated data. Um, so yeah, by the way, you can see like there's some shadow behind my back. It's more easy to see when there's a white background. Because my green screen is not stable yet. It will be. Don't worry. Maybe next week. Maybe next week. So um, yeah. Uh, so we want to have a smart way to store the data. So like we want to store it in a way that we call it like it's semantic. So you will have the context. You can have metadata to describe the context. You use ontology to map them into different things, and they would have their own properties, and each property will have their own domain, which is what things they're describing, and they will have their own range, which is like what format they are in. So yeah, how can we achieve that? Well, I just told you that we can't do it in a SQL relational database. So we need a graph database. So we need something structured, semantically meaningful, and it's rapid because we have lots of data. We want it fast because maybe we have a lot of users, they are researchers that want to get the data at the same time. So um, that's why we need TerminusDB. I would tell you why TerminusDB is good. Um, yeah, it's because well, first of all, it's open source. So now it's like free to use. It's free forever because it's open source. And uh, it stores things in a way that we call is in a OWL model. So OWL model is kind of like something out like an RDF, but it compared to RDF, it has more flexibility. It's more powerful, so you can really construct your own structure of the data. It's very flexible. Um, and it also speaks JSON LD. So if you have RDF format data, you can load it in through like even though it's in like turtle file, that it would just load it in into the database, and then it could talk to your AP like through an API, talk to your client in a JSON LD format. So it's fully flexible in a lot of applications. And then we use Wacko. It goes hand in hand with our TerminusDB, and is so the native Wacko is actually a JSON LD. So it's convenient to pass around as a query, but it also provides to clients in JavaScript and in Python. So if you say like, oh, I'm a programmer, I'm a coder, I write code, but I hate JSON LD because if you know what is JSON LD or JSON, it's not human readable. It's just like you can prettify it, but it's like super long. And but with our Waco.js, which is our JavaScript client, and Waco Py, which is within our Python client, then you just need to write in JavaScript or Python, and that's it. If I got a chance, like in the future, I would do another tutorial about Waco, so you see what I mean. It's actually very easy to construct within your JavaScript or Python code. Um, so yeah, you can build a very complex pipeline passing data around. Let the machines talk to each other by just passing around this JSON LD. Also, we use a technology called immutable append-only MVCC in-memory triple store. What does it mean? It just means that we can do things like it. Yeah, it's amazing. Because like we have the storage library in Rust, so it's robust, and we store things like Git. So everything would be like, so if you have new information, it's kind of like a new commit in Git. So you add a layer on top of your existing layer. So things will be fast, and also it allows you to just point back at some point. So it's like time traveling. You can also branch it off and uh, yeah, share the data with your friends or with your colleague. So I will talk about that later. We are now developing that. It's we call it Terminus Hub. It's not out yet, but we are developing it. It will be out very soon. So it's kind of like GitHub. You can share, collaborate, and branch and merge your data. So which is something that we need at this moment because in the old days, like you pass around CSV, let's say, and then you kind of send your, let's say you send your colleague an email and then put all the CSV in and say like, oh hey, this is the data you asked for, blah blah blah, and then when your colleague received it, like your colleague may have the old version of it, so like your colleague need to name it, rename it, oh final version, or oh the file that John sent me, or something like that. And also maybe your colleague doesn't know the data that well. So your colleague needs to come back and then send another email back to you. Oh, what does this column mean? What does that column mean? Well, it's very tedious. And before, if you are in the same office, you can just pop over and have a look together. Now, it's more complicated. You may have to, chat on Slack or, have a conference call to have a look together. It's tedious. So with TerminusDB, you can store the metadata in the graph as well. You can also, as I said, you can do all this version controlling. Things are more neat. It will require less communication on top of the data itself to express what it is. And also, it's high performance. It's fast. It's yeah, because we have a Prolog engine. So for people who know Prolog is, you will be like amazed. But people who don't know what Prolog is, like Prolog, we describe it as a logic engine, like a logical program. So basically, it's like some mathematical puzzles. You put in some requirements, and then Prolog will happily give you an answer. So instead of writing everything step by step, do this, do that, and then check this, check that, and then give me the result, Prolog will happily like, oh, you have this requirement, okay, I'll give you this as a result because this thing fulfilled the above two requirements without you writing every single step and telling your computer how to do all this logical reasoning. So that's why it's super fast. Is very robust and is surprisingly well. Like people are very surprised that we make use of Prolog and do this amazing stuff. So So why we store data in a graph? Why we don't like this? Like except that we have to do a million joins. It's not intuitive. Look at this table. Well, now like after you looking at it for a while, you may already know, oh, name. Well, there are some people here, and but they may be, students in a class. They may be an employee in a company. But maybe you look at father and mother. Oh, and then you start reasoning in your mind that, oh, maybe one and two are related because there's a two in mother. But who is related to who? You have to spend some time in your mind to map it out to make sense out of it. But look at this. If we put everything in a graph, then you would see that this is obviously a family tree. You can even color code your parents or grandparents by the gender, so you know who is grandpa, who is grandma, who is mother or father. And also, you can see that it's very obvious that who is your parental grandfather. It's very obvious because you don't even need to spend the time to map it out in your brain, because our brain doesn't work in a tabular format. Our brain works like a graph. So it is more intuitive to do things in a graph, to store data in a graph. It's actually easier to manipulate it. We thought that SQL is easy, but because through all these years of struggling and learning, we kind of get used to it. But once you get used to using a graph database, you will find that manipulating data in a graph is actually more direct and easy. So back to how we tackle the Shasha problem. So there's three, you can see. Like there's three RDF here. So I'm hiding this thing. Sorry, it's Shasha main graph RDF. This is what it says. And my green screen is falling off if I move, sorry. Um, so we have the main graph data here. We have the annotation, so it's some information on top of the main graph. Oh my god, my green screen is really, oh no, sorry. It will be fine next week, hopefully. Okay. Um, so we also got ontology, so we kind of relate other extra information to all these main resources that we have. For example, we have the polities, which is different societies, and then we would know more about like whether they have conflict with each other, what's their religions, and all these stuff about them. Even like in this region, do they have any minerals, or what are the military and all this stuff? It's very cool. You can see like we also have a lot of geographical information, a lot of Excel file. Oh my god, they are like CSV but worse. Because yeah, like if you are a Python programmer like me, you would probably use pandas to do data manipulation. Pandas work very well with CSVs, and they are flat files. They are super fast and linear. But Excel, because sometimes like business people pass me an Excel file, they have done a lot of calculation in it. It's not easy to read in pandas. um, and you would have a messy format, lose some data, and they have multiple pages as well, is horrible. I was like, ah, having my nightmare back. But like, you got this extra information in Excel or CSV format. Um, by the way, TerminusDB can handle not Excel but CSV perfectly. Excel maybe. We just need to write some other like tools to parse it, but I think it's doable. If we can do CSV, we can do Excel. It's just a little bit more tricky. So we put all this data together in our graph database in TerminusDB, and we would have from the graph database, actually, if researcher prefer CSV still, because they want an aggregated data, they don't care about if they have to. Actually, they don't have to do joins anymore because things are aggregated. They're just getting the result from it. Everything is already in the database. So when they get the data, they just need to make a WACO query, and they don't need to write million joins to aggregate stuff. They will already get it back what they want, and they can do the analysis easily. Um, Also, again, I'm hiding this. There's some arbitrary RDF graphs here. Sorry. There are some arbitrary model extensions, and there are some more inputs. So what we want to do here is that we want to build a pipeline that put all these models and graphs together. So even if we have something new, we can update what we already have, our model, and then get this input again, and then into an engine that actually self-serving. It could always be updated. It could also be collaborating, like maybe researcher want to put in new data that they found. Um, and then for their new publication, they can collaborate with other researchers, and it just make their life much easier. So in the original talk, I would give a demo here, but I think because this is a test streaming, I won't go into the modeling. Maybe next week I should try a live coding. That would be exciting, but I think this week I just want to keep it easy. So uh, I won't be showing you. I will save it till next time that maybe I would do a demo. Um, yeah, that's cool. Yeah, I would totally do it. I plan to do this regularly in case you missed the beginning. Um, yeah, live coding. Yeah, people love watching live coding. I would do that next week. Yeah, for sure. Um, so yeah. So after that, you build a schema, you build a model. I can show you next week. Um, so now I'm putting myself in it now. Okay, so yeah, I would show you maybe an easy example. This is super difficult. There will be like pages of. Oh, hey, okay, I'm back on. So yeah, there will be like pages of code. Yeah, I'm back on now, so I'm fine. Yeah, I don't want to show you pages of code. That would be more than an hour. And live streams should be, I think it should be light and easy. I'm not playing a game. It's difficult to keep you engaged. I'm not like shooting enemies or something. So I would keep it brief. But next time I would go to do maybe a tutorial. That would be easy and light and do some live coding, exciting. And you can ask questions or you can correct me of my typing mistakes. I have a lot, trust me. So yeah, that would be cool. Um, yeah, so skip those two parts now. And I'll jump to the conclusion. So actually, I've mentioned it before that we ultimately want to have a tool that uh, everybody, like not everybody, but like people you allow, like your teammates, to collaborate, like GitHub. But GitHub is built for developers. It's handled code very easily, but it's not necessarily good for data because how they treat the code is like, it's just a flat written, text file. It's without the structure because we said before, right? A lot of data is actually structured in a graph format. So you have to have a new tool that do what Git can do, let you collaborate, like pull, clone, merge, and push back. So we are building that now with TerminusDB. So you can use data in a graph with the structure that you built and collaborate with your teammates, your colleagues, or whoever was doing the research with you or building the application with you. So it's really like Git for data. Um, and yeah, and then maybe we'll have a publisher API for the Shasha project that they can easily publish a new paper according to their all their data that they have in the TerminusDB database. So yeah, I think it will be great. So if what I said interests you, you're very, very welcome to, first of all, follow me because I plan to do this regularly. But also you can, join our Slack channel, talk to me and my team, join a community, and we'll have webinar. So webinar will be more up and close. So here, now I don't have a lot of followers, but if I have a lot of people, it would be like more like, a big party. But webinar, you have to sign up, so it's like more like close. And I would also interview my colleagues about what the newest thing happening in TerminusDB, and you got to ask questions as well. Um, yeah, and people will come for sure. We will grow bigger. So thank you so much. Yeah, we will go back, and so join now. Follow us. Join our webinar. We try to have more webinar actually because we are all like in a work from home situation. People need to have some social kind of contact remotely. So we're here. So just find us. And yeah, so that's it for today. Now is almost half an hour. I think it's good for a start to keep it short and light. But yeah, next time live coding. Hoo. Yep. So I'll see you next time. You can give me suggestions. I have a suggestion box in Twitch. I'm trying it out. I haven't used it before, so feel free to do that. Or if you really want to be up and personal, you can join our Slack channel or find me on Twitter. Maybe you can find me at my profile in Twitch. I'm not sure. I'm new to Twitch, but yeah. So see you next time. Bye.